Hello everyone, how's it going? How's it going? Uh, I'll be starting the class in 2-3 minutes. Okay, let's wait for a few more people to join. Okay, so where did we left off the last class? We left off the last class after discussing merge sort. Okay, and then we looked at a few questions after merge sort. Okay, uh, sorry. Yeah, the inversion count also. What about the inversion count, Rachit? Yeah, yes, exactly, exactly. Yeah. So the question in the questions we discussed inversion count as well. Yes. Uh, okay. So I have shared my screen with you guys. So is my screen visible to everyone? Okay. Okay. Cool. Cool. Okay. So today what we will be covering is we will be covering the rest of the topics and like a few more sorting algorithms and we'll be doing a few more questions. Okay. So that's what today's class will be about. Okay, we are obviously not going to cover all the sorting algorithms that exist. Okay, we are trying to cover the most important ones and the ones that are asked the most frequently in all the interviews and all. So we're trying to cover those sorting algorithms. Okay. Uh, Firstly, there were a few questions from the last class which were left. Okay, which I was not able to discuss or I was not very sure about those. Okay, so one of the questions was about order of one merge of a sorted array, right? I forgot the name who asked the question. If the person has joined the class, can you please reply? So someone in the last class asked me in the merge sort when we were merging two arrays. Okay, so that can be done without using any extra space. Okay, that was the question that was asked. Okay, and I left that to be discussed in the next class. So if that person who asked the question is present, can he please reply? Is he yet to join? Okay. Okay. Then there was one more question that was more than two repetitions if there are there in the wave array. Okay. Then what should we do? Okay. This was also the question that was left for discussion. So the person that asked this question, is he there in the class? If you are there, please can you reply so that I can discuss those questions and then we can start with today's class. Okay. If not, then I'll be discussing them in the doubt session at the end then. Okay. Already 28 people have joined. Okay, I won't be waiting for much longer then. Then we can directly start with today's class. Okay, 30 people. Okay, so let's start with today's class. Okay. Uh, sure. So the first thing that we'll be doing is we'll start with a question. Okay, we'll start with a question. Okay, so the question is that you're given n buckets. Okay, and for these n buckets, you're given an array a of I. Okay, is this font clear? Like, is this visible to you, or should I increase or decrease this? Can okay, cool. Okay, so a of I is the radius of those buckets. Okay, so they are circular buckets, and we have the radius of those buckets given to us. Okay, and we can stack those buckets into each other if so. Basically, we can insert the ith bucket inside the jth bucket if the radius of the ith bucket is less than the jth bucket. Is that correct? Okay. So what our goal is to minimize the visible bottles. Okay. So let's say we are given this array 4, 1, 2, 5, 2 and 7. Okay. So this is the array given to us. Okay. And this is the radius of the buckets. Okay. So now what we have to do is we have to stack the buckets into each other. Okay. So that the minimum number of buckets are visible. Okay, can you please summarize the question once again? Oh yeah, okay, cool. So there are n buckets given, and the radius of the buckets is given to us. Okay, and we can stack one bucket into another if the radius of the ith bucket is less than the radius of the jth bucket. In that case, we can put the ith bucket inside the jth bucket. Okay, so what we have to do is, so once we put one bucket into the other, okay, only one bucket will be visible. Okay, so our question is to minimize the number of visible buckets. Okay, so let's suppose for this question, if we see, okay, for this question, uh, let's start with the minimum bucket. Okay, so the bucket with radius 1, we can put it inside the bucket with radius 2. The bucket with radius 2, we can put it inside the bucket with radius 4. Okay, the bucket with radius 4, we can put inside the bucket with radius 5, and the bucket with radius 5, we can put inside the bucket of radius 2. Okay, so one of the stack that would be formed will be, the bottom bucket will be 7, then 5, then 4, then 2, and then 1, and the other stack form would be of bucket 2. Okay, why we cannot put this bucket inside this bucket? Okay, Ankit, your solution is correct, but in your solution, why do we actually need to do the step 1? Okay, just think about this. Meanwhile, while I explain this problem, okay, we don't need to do the step 1 in your solution. Okay, so what will be the answer to this problem? The answer to this problem will be, there will be 2 visible stacks. Is that correct? Is this clear to everyone? Only one, yes. What about the others? Okay, cool. Okay, so now the point is, how will we do this? Okay, no two cannot fit into another two, because we have clearly mentioned the condition that a of I should be less than a of j for one bucket to fit into the another. Okay, now how will we do this? Anyone? Practically all of you have already done this. Okay, fitting one bucket into the other. All of you might have done this. Okay, so let's think, how exactly are we going to do this? Okay, Raj, you're correct. Rohit, correct. What about the others? Think how we can do this. Okay, so let's start. Okay, what will be the first approach that we can take? Okay, Arjit, remaining will increase the stack. No, Arjit, no. On unique ones, given to one, sort. Okay, Mayank, your approach is correct. Rajesh, not very clear. Arjit, seconds. Then no, Arjit, your approach will fail. Okay, why your approach will fail? I'll discuss this. Uh, yes, Ashish, your answer is also correct. Your answer is also correct. There will be two visible stacks. Okay, cool. Krizzle, your answer is also correct. Okay. Okay. Let's start. Okay. So the first approach, some of you have already guessed this. Let's say, let's first sort this given array. Okay. So if you sort this given array, what do we get? We get 1, 2, 2, 4, 5, and 7. Okay. Now, can we say one thing that since we are sorting in ascending order, for I less than j, the ith bucket can go into the jth bucket. Okay. Can we say this? No. Yes. Why no? Okay. Cool. Equal. Yes. Duplicates. Okay. So what we'll do is we'll start from the first element. Okay. We started from the first element. Okay. We keep one pointer here and the second pointer here. That is I here and j here. Okay. Now, can we see that we can put this I inside this j? Yes. So, okay. Since we can do this, we increment both I and j. J comes here. Okay. Sorry. Not this way. Okay. Just one moment. Okay, yeah. So I was here, J was here. What we're trying to do is we'll see whether we can fit the ith bucket in the jth bucket or not. Okay. So in the first case, we saw that we can do that. Okay. Since we did that, we increment I and j. So I comes here and j comes here. Now we'll see that whether we can put this I inside this j or not. Okay. So can we put this I inside this j? No, right? Why? Because they're equal. Okay. So whenever we come across this condition where we cannot put one bucket into the other, what we'll do is we'll increase one stack. Okay. What we'll do is we'll increase one stack. Okay. So then what we'll do is we'll increase one stack and we'll increment I and j. Okay. So the number of stack now what we have is one was the one that we started with. Okay. And now this is the additional stack. So the number of stacks now are 2. Is that clear? Okay. And again we increment I and j. Okay. So now the I is here and the j is here. Okay. Now can we put this I inside this j? Yes, we can. Okay. So this is so the first stack was 1 and 2. In the second stack, since we cannot put 2 again in 2, we started again with 2. Okay. Can we put this 2 inside this 4? Yes, we can put this 2 inside this 4. Okay. So we'll put this 2 inside this 4. Now we'll again increment our I and j. I comes here, j comes here. Can we again put this I inside this j? Yes, we can. Why? Because I is less than j. So 5. And again we increment our I, we increment our j. Okay. Can we put this I into j? Yes, we can put this I into j. Okay. So one of you gave this answer also as the answer. One of you gave this particular case also as the answer. So how many stacks that we have? We have one stack of 1 and 2 and the other stack of 2, 4, 5 and 7. Listening to you. Please tell. We were discussing. Uh, Milan, like since the class has started, I'll discuss your doubt at the end. Okay, in the doubt session, I'll discuss. Okay, and right now what we are discussing is we have n buckets. Okay, and we are given a array of radius of buckets. We can put one bucket into other if the radius of the ith bucket is less than the radius of the jth bucket. And what we need to do is we need to find the minimum number of stacks. Okay, so the first approach that we started was to sort the given array. And once we sort the array, if we start from left to right, we just have to check if we can put the left one inside the right one or not. And how we'll check that? The radius of right should be greater than the left, which will be there in case of the sorted array. Whenever we find the equal case, we have to make a new stack. Is that clear? Okay. So this was the first approach. Okay. And what will be the time complexity of this approach? No, Amit. Yeah, Raj correct. Amit wrong. Himanshu correct. Prashant wrong. Saurabh correct. Arijit correct. Shadab replied to me privately. Okay, so most of you are correct. That is, the time complexity will be order of n log n. Why order of n log n? Because sorting this array will take order of n log n time. Okay, and plus order of n. Order of n log n plus n. Okay, why? Because to traverse this array once will need order of n times, but we can overall call this as order of n log n. Okay, yeah, so most of you are correct. Okay, now there's one more approach to this problem. Okay, most of you have already guessed this, and those of you who haven't will be able to guess this from this particular case as well. So can you think of another approach to solve this problem? Okay, most of you have already replied. Okay, so that's okay for them. But others, can you think of another way to solve this problem? Okay, in a better time. Okay, everything is actually complicating. Think of a simpler approach. Okay, most of you have already guessed that. Uh, yeah, that's correct, Arjit. That would do good. Okay, so what we have to do is okay. No, right now we only want the count for it. We don't want the actual stack for it. We just want the minimum number of stacks that we can get. We don't want to know the like what all buckets will be there in the stack. We just want to know the number of counts because there are multiple possible answers to this solution. So we're just looking at the number now. Okay. So the second solution is that if you look at this particular case, when was a new stack created? In the array. I'll come to your point, Amit. Okay. So when was this particular new stack created? Whenever we found that there are two duplicate elements, right? Is that correct? Okay. And can I generalize this statement that okay, no two buckets of same radius can be a part of the same stack. No two buckets of same radius can be a part of the same stack. Is that correct? Okay. So can I say that the maximum frequency of any element in the array will be the number of stacks, will be the minimum number of stacks that will be required? Anyone have a doubt in what I just said? Anyone have any doubt? Okay. So let's take another example. Okay, let's take another example. Okay, and the other example is 1, 6, 3, 3, 4, 3, and 6. Okay. In this, we have two elements that are repeating. Okay. Yes, Milind, your answer is correct. This is what we will be doing. This is what I said, that the element with highest frequency, meaning the number which has the maximum duplicates. Okay. And the number of duplicates will be equal to the number of stacks that will be required. How? Okay, let's start with this problem. Okay, and let's follow the sorting approach which we did. Okay, so we'll first sort this given array. Okay, 1, 3, 3, 4, 6, and 6. Okay, 1, 3, 3, 3. Sorry, there are 3. 1, 3, 3, 3, 4, and 6 and 6. So we'll start from the first place. 1 can go into 3. Yes. So there will be one stack of 1, 3. Now can we put this 3 into this 3? No, we cannot put this 3 into this 3. So we'll have to start another stack. Again, can we put this 3 into this 3? No, we cannot put this 3 into this 3. So we'll again have to start another stack. Is that correct? Another start. Now can we put this 3 into this 4? Yes, we can put this 3 into this 4. Can we put this 4 into this 6? Yes, we can put this 4 into this 6. Okay. Now, for this 6, we have 2 more stacks available. Is that correct? So we can put any of these 2 into this 6. Okay. So let's say we put this into 6. So how many stacks are actually required? 3. Okay. Which is equal to the maximum number of repetition of any element. Is this clear now? If you have any doubts, you can ask. I'll explain again. No issues. Like if any doubt is there, please ask me. Yeah, this can be done without sorting. I was just explaining this. For example, okay, we'll not be using sorting in actually doing that. Okay. So now what we actually have to do is, we just have to find the maximum frequency of elements in the array. Is that correct? Is this clear with everyone? Okay, and how can we do that? Okay, correct. One of these approaches is correct. One is using hash map, we can do that. And a simpler way would be, we can, for those of you who have not studied maps, we'll be covering maps in the coming class. Okay, so one of the possible ways using hash map, and the other one is simply maintaining a frequency array. Okay, what's a frequency array? A frequency array is, let's say you have elements 0, 1, 1, 2, 2, 1, 3. Okay, what is the maximum element you have? 3. So what you'll do is you'll define an array of size 3. Okay, array of size 4, since it's a zero-based indexing. Okay, and for each index you will maintain the count of how many times that index has occurred in the given array. Okay, so how many times 0 has come? Once. How many times 1 has come? 3. How many times 2 has come? 2. How many times 3 has come? 1. And how much time will it take for us to make this frequency array? How much time will it actually take? Correct. And then how much time will it take to find the maximum number from this frequency array? Correct. So the overall time complexity, if we do it using a given array, is order of Yeah, correct. Order of range, you can say. And let's say if we do it using map, then the time complexity becomes order of n. Correct. Is this approach space efficient? It's space efficient if the range that we are using is not very high. We'll come to that point. We'll come to that point in a different question that we'll cover. Okay, we'll come to that point. But is this approach clear to everyone? So what we did was we just in the given array, we just counted. No, the array cannot have negative elements right now because the question is that we are looking for the radius of buckets. Is that correct? Anuj, is this clear to you? Okay, cool. Okay. Okay, so let's take another question. Okay, so before taking question, okay, and you know something. Maybe I can just repeat this example for those of you who joined late. I can repeat this example again in the doubt session, but let's not do this for the third time. Let's continue. Okay. Yeah. So now, most of us have come across a condition or a situation when there is some construction going around in our house, right? Okay. And what do you think is the most irritating thing when a construction is going on in our house, or let's say somewhere near our house? What's the most irritating thing? Yes, correct, correct, correct. So it's continuous banging noise of hammer drills, right? Correct. So noise of hammer drills is very irritating and it goes around for the whole day, right? Okay. And okay, so what do we actually use those hammer drills for? Breaking the floor. Okay, okay, okay. Okay, cool, cool. That's a different kind of construction you're looking at. Okay, I was calling for house construction. Okay, so yeah, yeah, inserting nails and stuff. Okay, and where do we insert nails? It's generally in the bolts that we insert nails. Okay, so the next problem is based on that only. Okay, so all of you must have tried this, right? Like if there are some nails and some bolts lying around, okay, and what will a OCD person do? He'll just pick up all the nails, pick up all the bolts, and start like looking for the right nail for the right bolt, okay, and screwing it, right? So let's say you're given n bolts and you're given n nuts, okay, and there is one bolt for one nut. Okay, so there is a one-to-one mapping. For each nut, you will definitely have a bolt. Okay, is this clear? Okay, so now what our question is that if you want to insert those nuts in those balls, okay, what will be the first thing that will come to your mind? How will you start doing that? What approach will you use if you want to insert all the nuts in all the bolts? Correct, Anuj, correct? Front, north, and two pointer. Okay. No, all are not of type same. All are distinct. All are distinct. For now, let's consider all are distinct. Okay. Take one nut. Check with all bolts. Sort both nuts and bolts. Keep making pair from starting. Okay. Okay. So some of you are saying that we can pick one nut. Okay. We can pick from for this particular nut. Let's start taking all the bolts one by one. Okay, and let's start by checking which one will fit. We'll tighten that screw and we'll keep that bolt and nut pair aside. Okay, so what will be the time complexity for this particular case? It's a basic brute force approach, right? Correct. Okay. Now, some of you suggested that, okay, let's first arrange all the screws according to their size, then arrange all the bolts according to their size, and then make one pair of each. Correct? So that is a sorting technique. What will be the time complexity for that? Is it ensured that every bolt will have a pairing nut? Yes. That's what I told, right? There is one-to-one pairing that every nut has a bolt for it. Clear, Mike? Okay. Yes. So the time complexity for that will be order of n log n. Yes. How? We have to first n log n for sorting, and then one by one matching is order of n. Correct? Okay. Now let's try to make the problem even more difficult. Okay. Now, while you were playing, one of your friends saw you and said, "This is very easy." Okay. Now, what the problem is that you cannot compare a nut with another nut, and you cannot compare the bolt with another bolt. Got the problem? No? Okay. So, let's say you're given 5 nuts, okay, and you're given 5 bolts. Okay. So, what do we do in sorting? We actually compare the nuts with each other, right? So in sorting, we compare all the nuts with each other and then we sort them. Then we compare all the bolt size with each other and we sort them. Now the problem is you're not allowed to compare the nut with another nut, and you're not allowed to compare the bolt with another bolt. So you can compare the nut and bolt, okay, but you cannot compare nut and bolt. Okay, so yeah, brute force will work in this case. Okay, why brute force will work? Because we were picking one nut and we were checking it for all the bolts. Then we were picking the second nut and we were checking it for all the bolts. Right? We are not doing a nut or bolt comparison as in case of sorting. First, put all bolts into hash. If you try to put all bolts into hash, then also there will be a comparison, right? To put into hash, there will be a comparison. Binary search for the right bolt with not. If we do a binary search, then for the binary search, we have to do sorting. And for sorting, we have to compare the nut with the other nut. Right? Right, Vishal? So that is not allowed. In the second step, traverse nuts with bolt. Soumitra is saying merge. So how do you merge, Soumitra? They are not sorted. Sorting was done by us. Now we are not allowed to do a sort. I can only think of order and square if we cannot compare net with both and both. Yes, we are given two different arrays, but they are not sorted. So how will you merge two unsorted arrays? Yeah, but sorting is not allowed to it because for sort we have to compare the size of nut with another nut, and that is not allowed. Yes, we have same number of nuts and bolts for the same size. Milind, please reply, please ask questions privately or answer privately. But yeah, that is what I have explained every time. Like 1:1 mapping is given to us. That is for each bolt we have a nut given. Sorting is again not allowed, Chirag. Okay. Okay. So let's get on with the solution. Okay. Let's get on with the solution. Okay. So let's say we are given nuts and bolts, and let's say they are represented by numbers. Okay. So the nuts are 4, 1, 2, 5, 2, and 7. Okay. They are labeled as this. Okay. Let's say it's some particular size parameter, or let's say it's a nut and bolt size 2, size 3, like paintbrushes, paintbrush size 1, 2. So similarly, we have a size in nut and bolt. Okay. and correspondingly, okay, correspondingly for every like for this is for the given nut, okay. For bolt also we will have the same thing, okay. For bolt also will be given the same thing. Just 1 second, sorry. Okay. Okay. For nut, for bolt, we are given 6, 1, 3, 2, 4, and 5. And for nuts, we are given 4, 1, 2, 3, 5, and 6. Okay. Sort the complete. Okay. So is the problem now clear to everyone? Okay. That we are so the 4 number bolt nut will actually get connected with the 4 number bolt. The 1 number nut will get connected with the 1 number bolt. Uh, the situation is clear to everyone, right? Okay, Anup, a very good solution is given. Anup, correct? Yeah. Yes, sir. Okay, some of you like directly jump to maps for all of the problems. Okay, so that's comparison is not allowed. So insertion into map is also not allowed. Okay, bucket sort. Even again, Ankit, comparison of a nut with another nut is not allowed. So the bucket sort will do what? It will compare A of I with A of I plus 1, and hence it's not the correct approach for this problem. Okay, Anup, you give the right solution. Okay, so let's start with the solution. Okay, how about if we take this nut, okay, and we like what do we have to do? We have to do is we have to find the correct bolt for this nut, right? So let's say if we start with this nut, there will be a bolt for this nut present in the array, exactly same matching bolt present in this array. Okay, so let's say what we do is we start sorry. Okay, so let's say we start from the left. Okay, and if the given element, okay, is greater than the element that we are comparing it with, okay, we keep it towards the right, and if the element is smaller than the element that we are comparing it with, we keep it towards the left. Okay, so how do we do that? Let's compare. Let's start from here. 6 is okay. I'll come to your problem. I'll come to what you're writing. Okay, so then 6 will come towards the right. What about 1? 1 will come towards the left. 3 is smaller than 4. 3 will come towards the left. 2 is also smaller than 4, so 2 will also come towards the left. Okay, and 4 is the and then the 4 we are already taking here. Then the last element is 5. 5 is greater than 4, so 5 will come towards the right. Okay, now if we take, so this one was the bolt array. Okay, and what we did was we took the first element as a pivot. Okay, and then we distributed the elements to the left and the right based on whether they are smaller than the pivot or they are larger. Is this correct? Is this clear? Okay, so we have not done a nut comparison or a bolt comparison. Okay, we took one bolt and we compared it with the nuts. Okay, now let's say we take this bolt and repeat the same process in the nut array. Okay, so we compare this nut and we repeat the same process in this array. Okay, so 4 will be our element, the pivot element. Now this 4 is already matching with this 4. The 1 comes towards the left as it is smaller. 2 also come towards the left. 3 also come towards the left. 5 come towards the right and 6 come towards the right. Okay. Now, can you see that we have already formed one pair? Okay. Is this clear? Okay. Okay. Now, can you observe that by dividing the elements using a pivot, now for these 3 bolts, okay, that is the bolt towards the left of the pivot, the nuts are also towards the left of the pivot. Correct? Is this clear? Any doubts on this? Okay. And similarly towards the right, okay, for this particular element, okay, towards the right of this, for these particular bolts, okay, the nuts are also towards the right. Okay. So what did we just do? We just divided our big problem, okay, this big problem into 2 smaller sub problems. This is problem number 1 and problem number 2. Is this clear? Okay. Now, what if we repeat the same process again in these sub problems? Okay. So we take this 1 as a pivot, okay, and we divide this particular array based upon that pivot. Okay. So we write this 1 here. Now this will be the bolt array. Sorry, the nut array. We're dividing the nut array now. Okay. So this 1 comes here. Now this 2 is greater than this 1, so 2 comes towards the right. 3 is also greater than 1, so 3 come towards the right. Okay. Now we again take the 1 here, that is the first element, the pivot element here, and then we divide the bolt array based upon that pivot element. So 1 will be directly coming under the pivot element, 3 again goes towards the right, and 2 again goes towards the right. Okay, so this part is sorted and it is again broken into a smaller subproblem. Okay, and if we repeat the same process, if we take this 2, okay, then the bolt array will be 2 will come here, and if we start 3 is greater than 2, so we keep 3 towards the right. Now we do the same process for the nut array with the pivot element 2. So 2 is equivalent to 2 and 3 comes towards the right. Okay. So now we got 1:1 mapping towards the left side. And similarly, if we do this for the right part, okay, we take the first element as our pivot, 6. Okay. Then 5 in the nut array, we start 5 come towards the left. So we place 5 towards the left. Okay. And then 6 comes as the pivot element, is equal to the pivot element. And similarly, if we take 6 as the pivot element again, and we start in the above array, 6 is matching with the pivot element and 5 comes towards the left. Okay, so we again got a mapping. Is this clear? Okay, okay. So what did we actually do in this? What we actually did was we selected one element. Okay, we used that element as a pivot, and we divided or partitioned our array into 2 based upon whether the elements are less than that pivot or greater than that pivot. Okay, so all the elements less than the pivot will go towards the left, and all the elements greater than the pivot will go towards the right. Okay, then we divided into 2 smaller subproblems. Again, we repeated the same process in those subproblems. Okay, and hence at the end, what did we get? At the end, we got the nut array as 1, 2, 3, 4, 5, 6, and the bolt array also as 1, 2, 3, 4, 5, 6. Okay, and we got 1-to-1 pairing of nuts and bolts. Is this clear? Any doubts till this part? Okay, what is the doubt? Can you please write? What's the confusion? Can you please ask? Yeah, I'll be writing the code for this part. I can write the code for this part. Not an issue. Any other confusion? Anything else than that? The code I'll be covering for this. Any other confusion than the code? Like, is this concept clear? What are we actually doing? Okay, 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 okay. I'll be coming to the code. I'll be coming to the code. Okay, okay. So now let's see what is the time complexity of this algorithm. Okay, so what is the time complexity of this algorithm? Any more cases? What will be the time complexity of this algorithm? Okay, okay. So let's try to write the time complexity Tn equal to. What are we actually trying to do? We are actually trying to divide our problem into similar subproblems. Okay, smaller subproblems, not similar subproblems. Sorry, smaller subproblems. Okay. Let's say if at each point of time we divide our array into two equal parts. Okay. Let's say if we find a pivot for which we get our array divided into two equal parts. Okay, let's suppose then our time complexity will become Tn by 2 plus order of n. By order of n to separate those elements by the pivot. Okay, partition those elements based on the pivot. Is this clear? Okay, so for this particular case, we have already we already know the solution for this particular case from merge sort, and the solution for this was n log n. Clear? Okay. But but okay, when we took 4 as the pivot for the first time. Okay, yeah, sorry. It will be 2Tn by 2. Sorry. Okay. So when we took 4 as the pivot for the first time, the subproblem size we got was 3 and 2. Okay. But for the next time, when we used 1 as the pivot, okay, when we used 1 as the pivot, the subproblem size was 3. Okay. And how much did it got reduced to? It got reduced to 2. Okay. Is this clear? Okay. So in this case, our subproblem did not break into halves, right? So this did not happen that the middle element became the pivot and we got two smaller subproblems, right? We just went from T of n to T of n minus 1, right? Why? Because the pivot was the smallest element, right? So if the pivot is the smallest element or the largest element, what will happen? It will be coming to the first position and our subproblem size will reduce only by 1. That's correct? Okay. Okay. So this will be the worst case scenario. In this case, our time complexity will be Tn equal to Tn minus 1 plus order of n again. Order of n for the pivot. Yes, Shadab, you're correct. Okay. Now, on every step, if you'll see, on every step, what will happen? Tn minus 1 will again be divided into Tn minus 2 plus order of n minus 1. Right? Plus this order of n is already coming. Is this correct? Okay. So what will this eventually come out to be till it will go to 1? Okay. So for each element, we are getting reduced by 1. Okay. So for n elements, will get reduced to 1. Okay. And what will it be? It will be a sum of AP n plus n minus 1 plus n minus 2 plus till 1. Right? So what will be? It will overall be order of n square. How? We just use the sum of an AP, okay? 2a into a, sorry, I don't remember the formula for the sum for AP, but if you calculate the sum for this sequence, it will come out to be Tn equal to order of n square. This is clear to everyone? Yeah, Milan. So that is what we are trying to do, right? If we sort them, okay, if we sort them, okay, yeah, it's also the sum of n natural number n into n plus 1 by 2, okay, so that's order of n square. So if we sort the array, that is, then we have the first nut and bolt as a pair, the second nut and bolt as a pair, the third nut and bolt as a pair, right? Okay, so that is one observation that Milind got from this, that what we are exactly doing is, what is the result of this pivot process is that we are getting a sorted array, right? Is this clear to everyone? Okay, okay, cool. Okay, so let's change this problem a little bit. Okay, now instead of two arrays, we are given a single array. Okay, 1, 3, 2, 4, 6, and 5. Okay, and no, it's not similar to brute force. Okay, I'll come to that. Only the worst case time complexity is order of n square. And when will the worst case be coming? I'll also be covering that. Okay, just wait for a few minutes. Okay, so now instead of two arrays, we are given just one array. Okay, and now it is allowed to compare the array elements with each other. Okay, now it is allowed to compare the array elements with each other. Can we use the pivot problem or the pivot solution discussed above to sort this given array? Okay, so what we'll do is, let's take any element as a pivot. Okay, so let's say we take for now the middle element as the pivot. Okay, so when we take the middle element as a pivot, sorry, this array is already sorted by the pivot. Let's take another example. Okay, the example will be 4, 1, 2, 3, 5, 6 that we had in the previous example only, previous question. Okay, and let's say we take the first element as the pivot again. Okay, so if we take the first element as pivot and we start traversing the array, okay, one is smaller than the first element. Okay, so one come towards the left, two is smaller than the element pivot element, so two also comes towards the left, three is smaller than the pivot element, so three also comes towards the left, five is greater than the pivot element, so five comes towards the right, and six is also greater than the pivot element, so six comes towards the right. Okay, now this is our pivot element. Okay, in this case the array already gets sorted, but if not, then what we'll do is we'll have two smaller subproblems. So what we can say is that all the elements towards the left are smaller than the pivot element, correct? And all the elements to the right are greater than the pivot element, correct? Correct. So can we deduce from this type, yes or no, that the pivot element is at the correct position in the array? Yes. So we got the pivot position on its sorted place, sorted index. Now what we need to do is we just need to sort the left subproblem and the right subproblem. Clear? Okay. Okay. So this particular sorting technique is called as quicksort. Okay, what is it called? Quicksort. Okay, and this is the most commonly used, and you can say it's the fastest sorting algorithm. Mostly, this is the one that is generally used. Okay, now some of you might be having a doubt on if the worst case time complexity is order of n square, why are we using this instead of merge sort? Correct? Okay, okay, I'll come to that. Okay, so let's first discuss. Can anyone tell me that in this particular sorting algorithm, okay, when, yeah, Milind, your answer is correct. When will we get the worst case time complexity? Okay, when will the worst case time complexity occur? Let's forget about the nut and bolt problem now. Now we just have one array. Correct, correct, correct. Okay, so most of you have already answered. When the array is sorted in descending order, okay. So let's say if we have an array 6, 5, 4, 3, and 2. Okay, if we take 6 as our pivot, okay, if we take 6, it does not matter if the array is sorted in ascending or descending order. In both the cases, we'll actually have can get the worst case scenario. Okay, so let's try with the descending case. Okay, if we take 6 as the pivot, we keep 6 here. Okay, 5 is smaller than 6, 4 is smaller than 6, 3 is smaller than 6, 2 is smaller than 6. Okay, so only 6 came to its right position, but all the other elements came as a part of our smaller subproblem. Is that correct? Now, again, if we take the first element as pivot, again, if we take 5 as pivot, okay, then what will happen? Then 6 is already at its right place, 5 will come here, okay. Okay, let's forget about 6 for a moment. We just have to sort this particular part. Okay, so let's take 5. Okay, then 4 is smaller than 5, 3 is smaller than 5, 2 is smaller than 5, and 6 is here. Okay, so only this particular element gets on its actual position. Okay, the sub problem is still consisting of 3 elements. Okay, and similarly, this process goes on till we take the last element as the pivot. Okay, so in this case, our time complexity will be order of n square. Is this correct? Is this clear, everyone? Okay, so this is just one particular case where our time complexity will be coming out as order of n square. Okay, now the best case time complexity was order of n log n. The worst case time complexity was order of n square. Let's discuss the average time complexity. Okay, let's discuss the average time complexity for this algorithm. Okay, so for average time complexity, what we are doing is let's say we take a random element. Okay, let's say on each iteration, okay, it's a hypothetical situation that we're imagining. Let's say for each iteration, okay, our array, okay, our complete array is divided into two sub arrays of 10% on the left and 90% on the right. Okay, so we are selecting any random pivot. Okay, clear? So we select any random pivot, okay, and our array is divided into two parts, 10% and 90%. Okay, so what will be our Tn in this case? Our Tn will be Tn by 10 plus T9n by 10 plus order of n. Why this order of n? Partition, correct. So this order of n is for partitioning the original array according to the pivot. Okay. So now let's imagine this with a tree diagram. Okay. So we have the size n here. Okay. It is divided into n by 10 and 9n by 10. Okay. And for this stage, what will be the time taken? Order of n. Why? Because we are pivoting the elements based upon that partition. Again, if this is divided into same way, what will we get? N by 10 square. Here will be get 9n by 10 square. Okay. Here also, if we divide it into two parts, we get 9n by 10 square. And here we get 9 by 10 whole square into n. Is this clear? We again divided our problem into smaller subproblems. Okay. Now what we do? If you consider this term, okay, if we keep on dividing it into subproblems, this term will very quickly become 1. Okay. Similarly, for this term also, it will very quickly become 1. Similarly, for this term also, it will very quickly become 1. Why? Because 10 is being raised in power. Okay. Whereas for this particular case, 9 by 10 whole square, this will be the main term which will actually take time to get solved, right? Is this clear? Okay. So 9 by 10 square, when it will again be multiplied by 9 and 10, will be uh, n by 10 cube and 9n by 10 cube. Okay. So you can see this term keeps getting smaller and smaller and smaller very quickly to the power of 10. Okay. But what will be this term in the next case? 9 by 10 to the power 3n, right? So this will be the term which will actually take time to get to 1. Yes, exactly. Okay. Again, for this particular step, what will be the time taken to do the partition? Order of n, right? For the next step also, what will be the time taken for the partition? So every time you have n elements, okay, and you have to overall compare those n elements, what will be the time taken for the partition? Order of n. For the next stage also order of n. How many times order of n? The time, how many times order of n? Equal to the height of the tree, right? Is this clear? Okay. So what will be the height of the tree? The height of the tree will be when this dominating subproblem will actually become of the size 1, right? That's what we do, right? We divide the subproblem, like for merge sort also, for quick sort also. We divide the subproblems till the size of the subproblem gets reduced to 1, right? So let's say that happens on some height k. Okay. So 9 by 10 to the power k into n equal to 1. And what we need to find that height k. Okay. So the value of n is equal to 9, 10 by n, 10 by 9 to the power k. Okay. So the value of k would be log of 10 by 9 base n, log of n base 10 by 9. Correct? Any doubts in this? If you have any doubts till now, please feel free and ask me what exactly your doubt is. Please ask. If anyone wants to ask, I can unmute that person. If you can message, I'll unmute you and you can ask your doubt. No? Should I continue? Okay, cool. So this is the height of the tree. Okay, and for each level, what is the time to make the partition? Order of n. So what will be the overall time complexity? T of n for average case will be, okay, in case of 9 and 10 partitions we are discussing, okay, it's just an average case we're trying to solve, will be n log 10 by 9 n, right? Because for each step we have, for each level of the tree we have to do n comparisons, and the height is log 10 by n, log n base 10 by n. So the overall time complexity is n into log n base 10 by n. Is this clear? Okay, so this is the average time complexity. Okay, this is the average time complexity. Okay, and for now, okay, so the worst case time complexity for quicksort will come on only a very special occurrence, that is when the array given to us is sorted. Otherwise, it will be this n into log base 10 by n. This will be the average time complexity, right? That is not this. Basically, it will be a log factor here, right? Instead of so basically 10 by n is the case where we actually got the partition in 10% and 90%, which won't be the case. But the average case time complexity will have a log factor here instead of n square, right? We can say this. Okay. Now for this case, okay, for this particular case, let's say if the value of n was 10 to the power 5. Okay. Let's say if the value of n was 10 to the power 5. What if the array is not sorted? In that case, it will be coming out to be this average case only. It won't be the worst case. The worst case comes only when the array is sorted. In that case, the array will be divided based upon that element you choose as a pivot. Okay. Then again, there will be two sub-problems. In those two sub-problems, if you again choose the last element as the pivot, then again those sub-problems will be divided based upon those elements. So in that case, you will never get the worst case. The worst case will come only when the array is sorted. Okay. Now, if we consider, for example, n equal to 10 to the power 5, okay, n square comes out somewhere to be near 10 to the power 10. Okay. So the time complexity for n square sorting algorithms will be somewhere in the range of 10 to the power 10. Okay. For merge sort, let's say for merge sort log 2 base n, the value of log 2 base log n base 2 of 10 to the power 5 is somewhere around 18. Okay, and let's say if we take this 10 by 9, okay, so log of 10 to the power 5 base 10 by 9, this somewhere come out to be 109. Okay. I'll come to your point also, Ashish. So if you'll just do a comparison here, okay, for the brute force or the n square algorithm, the time was in the range of 10 to the power 10. But here you can see, if we compare it to 10 to the power 10, both these values are very small, right? Although there is some difference between these values, but they are still very small. And the difference is very small if we compare it to n square, right? Is this clear? Okay. Now, what is actually observed is that when we take this quick sort for very large cases and we take the random pivot, the time comes out to be near merge sort algorithm only. Okay, it's almost near merge sort only. There's not much significant difference which is actually observed. Okay, it's just a random thing. Okay, so that's why we actually use quick sort at most of the places. Okay, Now, there's one more important question that comes to the mind that many of you have already asked on the chat is that if we are sure, one second, yeah. So if we are sure that merge sort will take n log n, even in the worst case, but for the quick sort, the worst case time complexity is order of n square. Why do we prefer quick sort over merge sort? Can anyone please tell why do we prefer quick sort over merge sort? Like, why will anyone prefer quick sort over merge sort if the time complexity for merge sort in worst case is also order of n log n, but in this case it is order of n square. Yes, correct, correct. Viday correct. Vishal correct. Amit correct. Vipul correct. Himanshu correct. Soumitra also correct. Shadab correct. Others can also take a guess. No, Shashi not correct. Yes, Ashish correct. Anup, you're also correct. Okay. So why? Because in merge sort, as we also saw that in the merge step, we require order of n extra space. Correct? Whereas in quick sort, we do not require any extra space. So the space complexity for quick sort is order of 1. Okay. That's why for large values of n, because of the space complexity, the merge sort, basically the quick sort, overpowers the merge sort and is actually seen to be performing faster in maximum cases for larger values of n because of its time constraint that we can solve quick sort in order of 1 time complexity. Is this clear? Okay. Now what I want is for you to first try to write the code for quick sort. Okay. Just take 2 minutes and try to write a pseudo code for quick sort. Okay. So what do we actually do? We take a pivot element. Okay. You can take any element as pivot for now. You can take the first element. You can take the last element. You can take the middle element. Okay. Take that is also quick sort, Himanshu. That is also quick sort. Okay. So take the pivot element, then we partition our array on the basis of the pivot element. Okay. And then we use quick sort again on the resulting sub-arrays, except that particular pivot element. Okay. So just try to write a code for this. Okay. And after that, I'll discuss the pseudo code for this particular problem, quick sort. Just try to think about that. If you're not able to do this, I'll be writing the code mill. I'll be writing both the quicksort code and the partition code as well. Okay. Anyone if you able to write that code, the pseudo code? No. Correct. Shadab, correct. Anyone else? Okay. Okay. So let me start writing the code. Okay. So I'll start writing the pseudo code for this quicksort. Okay. So okay. Now, first thing is the base case, and the base case is if low is less than high. So low should always be less than high. If low becomes greater than high, then that means greater than or equal to high. That means that we have reached our smallest subproblem, that is of size 1. Okay. Uh, what we do is we first find the partition around which we have divided our array. Okay. We do a partition of array low and high. Okay. Once we have that partition, what we do is we again call the quicksort method for this array for index low to partition -1. That is, the pi is equal to the index at where our pivot element will be. Okay, because that pivot element will actually be at its correct position, right? Is this clear? Okay, so this one is actually calling quicksort on the left subpart. Okay, and then again we'll call quicksort on the right subpart. Is this clear? So this is the quicksort part. Now we'll come to the pivot, the partition thing. Okay, since most of you had a doubt in the partition thing only. Okay. Now let's say we take the last element as pivot. Okay, you can take the first element as pivot, you can take the middle element as pivot. In this condition, in this case, I'm taking the last element as pivot. Okay. So pivot equal to array of high. That is the last element. Okay. Now what we do? We initialize a variable I equal to low -1. You can also initialize it as low, but it is better in this case. Now what we do? We initialize another variable j. Okay. So for pivot, what we did was, okay, I'll first write the code and then I'll explain. Okay. Okay. We'll write the list. Okay. So what we are doing here is we're taking one variable I. Okay. So let's say this is our array. Okay. We took this element as pivot. Okay. And what we do is we start from this index. Okay. So we start from the first index. If this element is less than the pivot, that means it will come towards the left of the pivot. Is that correct? If the element is less than the pivot, it will come towards the left of the pivot. Okay. So what we do is we increment I comes here. Okay. And we swap this element with I. In first case, the swapping would not happen. Okay. Now let's say we come to the second element. Okay. For the second element, if this is greater than pivot, we don't do anything. For the third element, our I is still here. Okay. Our J is here. If this element is less than pivot, okay, what we do, we increment I, our I comes here. Okay. And we swap this. Okay. We swap this with this J. Okay. And we increment I. So our pointer comes here. Then we go ahead and compare this element. So what will, okay, just 1 minute, I'll explain again. Okay. So what will happen here is all the elements that are smaller than the pivot, okay, in the array will start coming towards the left at the first position, second position, third position, fourth position, so on. Okay. Till we move from left to the right. Okay. Yeah, I'll explain with numbers also. Okay, let's take that would be a better case. Okay, so let's say we have 3, 2, 5, 6, 1, and 7. Okay, this is the array. Okay, uh, 0, 1, 2, 3, 4, and 5. Okay, we take this as our pivot. Okay, we initialize I as low minus 1, that is, we initialize I equal to minus 1. Okay, we initialize I equal to minus 1. Okay, now I compare this with 7. Okay, 3 is smaller than 7. So what I do, I increment. So in first case, j is equal to, here I is equal to minus 1 and j equal to 0. Okay, so 3 is smaller than 7. So what I do, I increment I equal to 0. And what I do, I swap ai and aj. In this case, they are both the same. So let's say let's change this. If this is 7, then we won't get to see. Let's say this is 4. Okay. So for the first case, this is smaller than this, so this will come towards the left. Okay. So since they are both the same, we don't need to do the swap. So then we increment our j. We come to the second position. Again, 4 is smaller than 2. We increment our I. Okay. Again, we do a swap, but they're again the same. We don't need to do anything. Then we again increment our j, we reach here. 5 is greater than 4, so we don't do anything. Then we again go ahead. 6 is also greater than 4, so we don't do anything. Again we go ahead. 1 is smaller than 4. So what we do, we again increment our I equal to 2. And what we do, we swap array of I, that is this element, and array of j, that is this element. So what we do a swap. Okay, so 5 comes here, 1 comes here. Okay, now can you say that all the elements to the left of this are smaller than 4? All the elements to the left of our I till our I are smaller than 4, right? The index size including for this pseudocode, this is inclusive. So we are also including the high. So high will be calling I as n minus 1 when we'll be calling the basement. Okay. So in this case, all the elements towards the left are less than 4. Okay. Now what we'll do is we'll swap array of I plus 1. Okay. After exiting this loop, we'll swap array of I plus 1 and array of high. Okay, that is our pivot element, because all these elements are smaller than 4, so 4 will come here. So what we do, we swap this with our pivot element. Okay, so 4 comes here, 6 comes here. Okay, so now can you see all the elements towards the left are smaller than the pivot element, and all the elements towards the right are greater than the pivot element, right? Yeah, I'm coming to that. I'll write that. And after that, we return the position of the pivot, that is I plus 1. Is the partition code clear? Any doubts in the partition code, please ask. Any doubts in the partition code, please ask. I'll explain the whole code again if you have any doubt. Okay, no doubts in the partition code. So shall I move on? Okay, cool. Okay, so this was quicksort, okay, which is the most commonly used algorithm for sorting, okay, and this is also preferred over merge sort because of its space advantage. So in the above code, you all saw that we had to use no extra space, okay. Just order of one extra space will be required to do the swapping. Otherwise, we did the partitioning part in order of one extra space. Is that correct? So is the space thing clear to everyone now, how we can do the partition in order of one time complexity? Okay, cool. Now let's take another question. Okay, what's the question that I'll be taking? Uh, let's say we are given uh, a range. Okay, what is the range? We're given 0 to 2. Okay, that is all the elements that we have will lie between 0 to 2. Okay, and we are given an array. Okay, let's say for example, okay, for example, let's say the input array was 1 0 0 2 1 0 and 2. Okay, so the range of all the elements will are in our array will be between 0 and 2. So all the elements, no. Finding the second and knowledge. Yeah, you can do using that also. You can do using that also. Yeah, you can using that also. That can also be done. Okay. Yeah. So continuing with this question. Okay, you're given this array, and what you need to do is you need to sort this. Okay. So how will you do this? What is the first thing that comes to your mind when you're asked to do a sorting? Yes, Krida, you are correct. So what's the first thing that comes to your mind when you're asked to sort this? If you don't know any other algorithm, what will you be doing? Okay. Most of you are okay. Cool. So I got some answers. Okay, I got some answers. Okay. So the first thing you can do is you can use any sorting algorithm. Okay, and in that you will get order of n log n. Okay, but can we do better than n log n? Can we do better than n log n? With the given constraint that all the elements given to us will lie in this range. No, Shashi, that will not be required. That will not be required. Time complexity, yes, we can do this in order n, but how will we do this in order n? No, bucket sort will take order of n square million. And Milind, please reply to me privately. Like you can see on the chat to everyone, you can select my name. You can reply to me privately for any answers. Okay. So let's try to look at this. Okay. Some of you have given the correct answer. Okay. So some of you have given the correct answer, that is using a frequency array. Okay. Now, what is a frequency array? I've already explained to you. Okay. So let's take an array of size 3. Okay. Let's take an array of size 3. Its index will be 0, 1, 2. Okay. Now, if we iterate through our array once, okay, and count the number of occurrences of all, okay, so how many times, like basically we have to do this in order of n only. only one iteration. So what we do is we initialize all of them with 0 and we keep incrementing them. So how many times 0 is coming? 3 times. How many times 1 is coming? 2 times. How many times 2 is coming? 2 times. Okay. Is this clear to everyone till this? So what we did was, from our given array, we just created a frequency array. Clear? Okay. Now, can you say, so all the indexes that we have, they are in sorted order, right? So now, can you create our output array, okay, from this frequency array? I want more yes, more yes. So can you create the output array from this frequency array? Okay, how do we do that? So what is the what is there on the 0th position? It is the number of occurrence of 0 in our given array. What is there on the first position? The number of occurrence of 2, or the number of occurrence of 1 in our given array. And what is there on the second index? The number of occurrence of 2 in our given array. And they are in sorted order. So we can start iterating from the left. Okay. So 0 occurred 3 times. So what we can do? We can add 0, 0, 0. Right? These will be the first 3 elements of our array. Is this clear? Okay. Then we come to 1. How many times 1 came? 2 times. Right? And how many times 2 came? 2 times. So this is our output array. Right? Is this clear? Yeah, Ankur, I'm coming to that. I'm coming to that only. It's a good. Okay. Yes, Vipul, that's correct. That's a limitation that we have. Uh, You can compute mod with minimum element of range and increment those indices. Yes, that's exactly what we'll be doing. So if the range is more than that, we'll compute mod with the element, mod with the index, and increment that particular index. Okay, we'll be coming to this. So is this part clear to everyone, that if the range is given to us, okay, then from the range we can create a frequency array, and from the frequency array we can create our output sorted array, right? So if we generalize this, okay, if we generalize this, okay, so instead of 0 to m, okay, our range is some a to b, okay, and where b minus a is equal to n, okay, let's say m, okay, b minus a equal to m, okay. So what will be the size of the frequency array that we will have to create? What will be the size of the frequency array that we'll have to create in case of general this? Correct. No, Vishal, you're not correct. So most of you are guessed right. The size would be m plus 1, because a and b are both inclusive. Okay. So as in case of 0 to 2, you can see 2 minus 0 is 2 plus 1. The size was 3 because we are including both the elements. Okay. So the size will be m plus 1, sorry. So the space complexity will be order of m plus 1, or you can say order of m. Okay. Now, how much time will it take? Okay, what will be the, let's now discuss the time complexity. Okay, time complexity. So how much time will it take for us to create the frequency array from our input array? How much time will it take for us to create the frequency array from the input array? Correct? So that would be order of n. Okay. Now, how much time will it take for creating the output array again from the frequency array? How much time will it take for us to create the output array again from the frequency array? Correct, Ashish, correct? Vipul, no. Rajesh, no. Others, please also. So from the frequency array, we have to create our output array, and how much time will it take? Yes, Kridai, correct. No, Saurav, not correct. No, Milind, not correct. So the frequency array is of size m, right? And how much time will it take? Yes, Ankur, you are correct. How much time will it take to iterate over an array of size m? Because we'll have to iterate over the whole frequency array, right? To see what is the count of each element, right? So how much time will it take? Those of you who have answered it incorrectly, can you please answer again if you got the point? So we have to iterate over the whole frequency array. Okay, yeah, correct. Nikita, you answered the whole time, the complete time. No, you're not correct, Nikita. We are iterating only once over this array, and in the same time, we can create this output array as well. Correct? So that would be order of m, right? So the overall time complexity would be order of m plus n. Is this clear to everyone? No, Milan, we are not appending each element every time. So suppose we come here at the first element. Okay. So for the first element here, we get it's of size 3. So we just add 3 zeros to this array. Okay. It won't be, so we are not doing this loop n time. So we are not iterating over the output array n times, or the number of times we are traversing this array. We are doing both the process simultaneously. You got the point, Milan? Yes, Milan.
Hello. Hello.
Yes, Milan.
Ayush, what I'm saying is that let's say we talk about this 3 to 2, right?
Okay.
When we are at the 0th index, then I will like run a loop 3 times to append a 0, 3 times to a let's say a new vector or new array list or a new list maybe. And then I will iterate again to the index 1, then I'll append 1 again 2 times. So even if we are iterating like m times through that, but we are appending in sum total, it will be n, right? We can't, I mean, we can't directly create an array of size 3 with all the indexes, like all the value at the first 3 indexes 0. Are you getting what I'm saying?
Yes. I'm getting your like I'm getting your doubt. What you're trying to ask. So what you're trying to ask is that in hello.
Hello.
Yeah, I got your question. So what you are trying to ask is that during creating the array, okay, from a particular this range,
Yeah, frequency array. Yeah.
Okay. Yeah. So creating this from our frequency array. Okay. We are iterating n square times, right?
No, no, n times, n times.
And yeah, yeah.
Total, in total, like it will be still be n. I mean, it's not possible to like create more from something in which was supposed to be created in original time, but we are creating it in less time.
Just, just a moment. Okay, I'll explain it to you. How we are actually.
Yeah, this is as what Chirag says that three insert costs also add up. So we are inserting it like appending or inserting at the end.
1 second. Sorry, my screen got lost.
It will be different in this.
I'm really sorry. My screen actually got lost. Okay, sorry. Just 1 second. Okay. Me think about this. I also got stuck on this. It's actually order of m plus n only. Okay, but I'm also thinking it how we're going to do this from the frequency array. Okay.
Hello? The
Just
screen is not visible, Ayush.
sorry. Is my screen visible now?
Let me refresh.
Is it still not visible? My screen? Let me reconnect. Let me reconnect if my screen is not visible. Just 1 minute. Just 1 minute. I'll reconnect. Hello.
Hello.
Yeah, am I audible?
Yes, you are.
Okay. I think there's a problem with this. I'm just looking at why my iPad screen is not visible to you guys. Okay, is it visible now?
Yes, yes.
Okay, okay, cool. Sorry for this. Sorry for this. Okay. Yeah. So, so this was what we were discussing at how we will actually loop to create the array in order of m time instead of order of uh, hello.
Yeah, I'm listening. I'm here.
Yes. So order of m time instead of order of uh, that. Sorry. Okay. So how the loop will be running is that how the loop will be running is that for okay I equal to 0 uh, not 0 let's say uh, yeah cool for I equal to 0 and array of I and I plus plus okay so the condition that we are keeping here hello
Yeah, yes, I can hear you, Ayush.
so the condition that we are keeping here is till we don't get the array of I that we have till 0
Okay.
okay clear and the output array that we are creating okay
Yeah.
okay now for the output array what we do is uh, so let's say yeah so basically 1 plus 3 I'm sorry I actually got stuck at somewhere I myself got confused in this
No, there is something that can you look at Amit is saying like so, so I can't understand what that means. I think what Krida is also saying like sometimes the range is greater than the input array. So in that case it will be
in this case when you reach at 1 in frequency array then your loop for output creation will run n times
so you can unmute them and we can get to know like I can get to know what does that mean.
sure yes Amit
Hi. So basically, what I was saying is that suppose there is you have only ones in your array.
mm-hmm.
So basically, your input array is all ones. There is only one on the whole array. So when you create the frequency array, suppose the range was 0 to 2. So your the range frequency of 0 will be 0. Frequency of 1 will be n, and the frequency of 2 will be 0. Now you will iterate over the frequency array for I equal to 0 to 2, which is equal to m. And inside you will iterate over the count, that is for j equal to 0 to j less than frequency of frequency of frequency array of I and j plus plus. So this will be this second loop will run 0 times in the when I is 0, but when I is equal to 1, the second loop will be running n times.
So that would be like that would be still be n, right? So that would be the size of the array input array. So it will be n.
No, what I'm
no.
trying
You
no what
you have
what
two
I'm trying to just
Milind, here
one
you have two arrays, right?
wait
Second
wait
group is inside the first one.
just wait for 1 second, okay? Listen to what I'm trying to say, okay? So when the outside loop is running, okay, for m time, hello,
Yeah, yeah.
okay, so the outside loop is running for m times, okay, and when you go ahead and start running the inside loop,
Okay.
okay, will the inside loop be running n times for each iteration?
No.
No, right?
No,
I
I had
mean,
one
there might be
example.
a case, but
No,
not
in any case,
essentially.
you
No.
consider that because the total number of elements, okay, the total number of, if you overall, like what I was trying to say was, if you, like, if you do the sum of all the values of the frequency array, you will get n, right?
Yeah,
Yes.
yeah.
So, the inside loop, if you'll do a summation over how many times the inside loop is running in total,
We will get n.
we'll get n only, right?
Yeah.
Correct?
Uh-huh.
And how many times what is the time complexity of the outside loop?
No, no, that's how we calculate the time complexity. Let's say we have two loops
No. So,
who are running which are running n times.
yeah. We
So,
calculate that time complexity if we are actually looping over the whole array, right?
uh-huh.
Right?
No, but that's the way to calculate the time complexity, right?
What?
We like for every iteration, how many times let's say we have two loops, and for let's say the outer one is running for m times and the inner one is running for n times.
Okay.
All right. So
So,
then it will be m into n, right? That
yeah,
is, we are summing n time n plus n plus m plus n, like
yeah,
m times we are doing that.
but for
Mm.
the inner loop,
Yeah.
okay, the inner loop is running for the complete array for all the m times, right?
Okay.
So if the outside loop is running for m times,
Okay.
the
Okay.
inner loop is running for each m for the complete array.
Okay.
But
Yeah.
in this case, we are not doing that. We are just covering up our array. So if for the previous case we covered till here, for the next case we'll just cover till here, only this part. So overall, the inner loop will be running only for the complete array. It will be running only once, right? No, it
Okay.
won't be running over the complete array for each iteration of m. Is this clear to you? What
Yeah.
I'm
Yeah. I get
saying?
it. So what you were trying to
Yes.
say, like if the input array is if empty, let's say, but
Okay.
the range is let's say 1 to m,
Hmm.
so then it will be m.
Yes, then it will be m.
Okay. Got it. Got it.
Got the point?
Yeah. Got it.
Okay. Okay. Uh, yes, the overall time complexity for this comes out to be order of m plus n. Okay, and why order of m plus n? Order of m for looping over the array, and actually 2n. Okay, for covering one for creating the frequency array from the input array, and another n for actually filling up the input array. Is this point clear to everyone now? Or someone still has any doubt in this? Okay. So the overall time complexity becomes order of m plus n. Okay. Now, whichever term is more dominating will take over. The range is big. Okay. The range term will take over, and if the size of the array is big, the size term will take over. Okay. Is this clear? Is my voice clear now? Is my voice breaking for everybody or just for me? Hello? Hello? Am I audible? I'm audible to one audio, but inside this Hello. Is it clear now? Okay, cool. So I'll just share my screen. Okay, cool. Sorry for this audio interruption. I don't know why it happened. My Wi-Fi is also working fine. Okay, so let's move on. Okay, let's move on with this. Okay, so we were actually doing the question above, and the question was that the range given to us for the array is from 0 to 2. Okay, and the input array that is given to us is 1 0 0 2 1 0 and 2. Okay, so one approach that was given by everyone was to use the counting sort. Okay, just once again, the algorithm that we used just now. Okay, to so okay, what we did was from the input array we created a frequency array, and from the frequency array we created the output array, right? And the time complexity for this is order of m plus n, where m is our range and n is the size of the array. Correct? Clear to everyone? Okay. So this particular sorting algorithm is known as counting sort. Okay. So why it is called as counting sort? It is called as counting sort because what we are doing, we are just counting the occurrence of each number or each integer inside the array, and we are creating a frequency array from that, and from the frequency array we are creating our output array back. Clear? Okay. Again, one thing that we noticed was that the time complexity is linear. Okay, so this is the first sorting algorithm that we have studied till now with a linear time complexity. Right? Clear? Okay. Now the question comes is, if the time complexity for the counting sort is linear, okay, what is the disadvantage and why don't we use the time counting sort instead of quick sort or merge sort? Can anyone guess? If it's a linear algorithm, okay, and time complexity is linear, better than quick sort, better than merge sort, why don't we use this? Himanshu correct, Kridai correct, Saumitra correct, Vipul correct. Please answer to me privately. Shashi correct, Amit correct. Okay. So let's just take for an example where the range of numbers is from minus 10 to the power 2 to 10 to the power 2. Okay. Let's say the range is from minus 10 to the power 2 to 10 to the power 2. Will counting sort be a good method to use here? Actually it is, because why? Because it's a very small range. Okay, it's not a very huge range when you compare it to the numbers actually. But let's say if the range is minus 10 to the power 15, okay, to 10 to the power 10, let's say. In this case, will counting sort be a good way to use? No, right? So, by experiments, what it is generally observed is that in case the range is nearly 10 to the power 5 or 6, in those cases, counting sort can be used. Okay, in those cases, counting sort can be used. But if the range exceeds these, it's preferred to use quick sort. Okay, or merge sort, whichever is mainly depending upon the question. Okay, clear? Okay, cool. Now, okay. Now let's come back to the question that we were actually discussing. Okay, that question. So the range is 0 to 2. Okay, and the input is 1 0 0 2 1 0 2. Okay. So what we did was we used the counting sort algorithm to create a frequency array from the given input array. Okay, and from the input array we created the output array. From the frequency array we created the output array, right? How many iterations we had to do? Not the time complexity. How many times we had to iterate over these arrays? Two, three, two. Okay, basically 3 times. Once to create the frequency array, then once over the frequency array, and once again to create the output array. Right? 3 iterations. Can this particular problem, okay, only this particular problem where our range is 0 to 2 and this is our input can vary, okay, can this be done in a single iteration? Can anyone think of a solution where this question, where we have this range and we have to sort this, can this be done in a single iteration? Think about it. Yes, Ankur, correct. Amit, correct. Amit, your previous answer was correct. Yes, exactly. Exactly what you're trying to say, Amit. Something like this, but a generalized, like not exactly this, but something like this. Correct, Himanshu, correct. Amit, correct. Yes, correct, correct. Okay, so most of you have, some of you have guessed this. Okay, so what we can do is, for these 3 elements, 0, 1, and 2, okay, for these 3 elements, is it certain that all the zeros will be coming towards the left and all the 2's will be coming towards the right? Right? So what if we maintain 2 pointers here, I and J? Okay. Before starting, we just ensure that I does not point to 0 and J does not point to 2, because they will already be in their correct position. Okay, so I is not pointing to 2, J is not pointing to, J is pointing to 2, so we decrease J1 and we come here. Is this clear? Now what we do, we start iterating from this place. Whenever we encounter 0, we swap it with I and we increment our I. Whenever we encounter a 2, we swap it with J and decrement Rj. Correct? So what will happen? All the zeros will come towards the left, all the 2's will go towards the right, and what will be left in the center will be all 1's. Right? So let's start this. We have a 1 here, we don't do anything. At this position we encounter a 0. Okay, so what we do, we swap this 0 with the I. Okay, so this 0 goes here. Okay, and 1 goes here. Okay, now we again increment our I. Okay, again we find the 0. Again we increment this. I is pointed here. Okay, we go to the next element. The next element is again 0. So we again do a swap with I. Okay, again 1 comes here, 0 comes here. Okay, what we do, we again increment our I. So now I is pointing here. We go to our next element. The next element is 2. Okay, so we will swap 2 with the j, that is towards the right. So we swap 2 here. Okay, we swap 2 here. So 0 comes here, 2 comes here. Okay, now our I is still here and we decrease our j. So where does j points now? J points here. Okay, now shall we move on to the next number? Think about it. Shall we move on to the next number as we were doing in the previous conditions? No, right? Why? Because on swapping we encountered a 0. Okay, and since we encountered a 0, we have to again swap it towards the left with our I. So what we'll do, we'll again swap this with I. Okay, so 0 comes here, 1 comes here. Okay, and then we can move ahead. Okay, so the condition of moving ahead in this case, can you please again how you are swapping? How I am swapping? Just 1 second. Hello, hi Nikita.
Yeah, I just want to know how you are swapping the value 0 and 2. Means like if we are at, if initially the array is like 0, 0, 0, 1, 1, 2, 2 and I is at 0th position and j is in 4th position. So when we encounter first 0, so which 2 elements we are swapping? Like
If we encounter a 0 towards the left, we don't have to swap, right?
no, towards right. If we encounter first 0 towards right, how we are swapping the values?
If we encounter first 0 towards right, meaning? This is the array
initially,
this is
initially this array was like 0, 1, 0, 0, 2, 1, 0, 2 and j was, yeah. So now
Okay.
if we encounter first 0, how
Okay.
you are swapping the values?
Okay, so we are initializing I as the 0th index and j as the last index. Okay.
Yes.
Is my screen visible to you, Nikita?
Yes.
So Ankit, it's a problem with your connection then. So okay, now towards the left all the zeros will be there and towards the right all the 2 will be there. Is this correct?
Yes.
So on j you can already see we have a 2.
Hmm.
So this position does not require a swap. Okay. So from the left we start a loop. Okay. Suppose there was 0 here. There was a 0 here. Okay. So we wouldn't start from here because this is already a 0. Where we'll start? At the position where we'll encounter a first non-zero number.
Yes.
Okay. And from the right, from where we'll start, where we'll encounter the first non-2. Okay. So we started from these 2 positions.
Yes.
Okay.
Now for 0 is there.
Yeah. Sorry. So let's again get on with our problem, what you asked. Okay. So our I is here. Okay. Our j is here. Is this clear to you?
Yes.
Is this clear to you? Okay. Our I is here and our j is here. Okay. So now we start iterating from the left. Okay. We found a 1. Okay. So are we swapping 1? No, we are not swapping. We are only swapping 0 and 2.
Yes.
Okay. Then we move to the next position. We encounter 0. Okay. So where do we swap 0? Towards the left or towards the right?
Towards the left only. It will remain
right?
the same.
Okay.
Yes.
And we are maintaining I as the position of the first non-zero number, right? All the numbers before I are 0.
Okay.
Okay.
Understood.
So what position will we be swapping? Let's say this iteration, this was being maintained by k. So with what position will we be swapping this k? from where we have initialized the I, right?
Yes.
Is this clear?
Hmm.
So this 0 goes here and 1 comes here. Is this clear?
Yes, yes.
Okay. Once the swapping is done, we increment our I. Okay.
Understood. Yes.
Clear? The doubt is clear?
Yes. Yes, 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 clear. Thank you.
Okay. Okay. So now one condition that we discussed here was that we cannot swap until unless we get a 1. We cannot increment our pointer until unless we get a 1. Why? Because there's a possibility that from right swap or either left swap, there's a possibility that from the left swap we get a 2 here, or from the right swap we get a 0 here, right? But if we get a 1 to our swap position, do we need to worry about that? No, right? Because we are not swapping ones. Okay, so I'll write the code for this. Okay, I'll write the code for this. Okay, so the code will be if a of k, k is our traversal pointer, equal to 0. Okay, so a of k is 0. What do? We swap I and k, right? We swap a of I with a of k. Okay, and then we increment our I, right? If a of k equal to 2, okay, then what we do? We swap a of k with a of j, okay, and we decrease our j, okay, and now we check if a of k is not equal to, or let's say if a of k is equal to 1, okay, then what do? In that case, we increment our k, because we don't have to do any more swapping. Yes, Ankur, we can do that. We can do that also. Is this clear to everyone? Is this clear to everyone? Anyone have any doubt in this question, in this particular question? Any doubt? No, right? Okay, cool. Okay. Shall we move on to the next algorithm? Just one more algorithm we can discuss and then we can close this class. Will that be okay? Okay, cool. So we'll start with a question only, okay? What's the question? You're given an array, okay? And in the array, you are given numbers, okay? 361, 4, 432, 12, 78, 500, and 112. Okay? Now, what you have to do is, you have to sort these numbers by its 1th position. Okay? That is this position. Sorry. Okay? You have to sort these numbers by the 1th position. Is the question clear to everybody? Okay. So by the 1th position means that you just have to consider this particular number, okay, and sort this. What if they are the same? If they are the same, the one that is coming like the one that is coming first in the array will be coming first in the sorted array as well, if they are the same. Okay, so in this case, I'll just do a dry run on how. Okay, so if we consider the 1th position, which is the lowest number, 0, right? So 500 will come first. Then we have 1, okay, and we have 1 only in 361. Then we have 2. How many 2s we have? 1, 2, and 3. Okay, so answering your question, Rajkiran, if they are same, the one that's occurring first in the array will be coming first in the sorted array as well, which will be 432, then 12, and then 112. Okay, and then when at the end we have 78. Is the question clear to you? Okay. Rohit, we can do that, but can you think of something better? Okay, think of something that we have just used. Can anyone think of any solution? Yes, Himanshu, that we will have to do. We will have to maintain that pair. Yes, Adil, correct. But please try to reply privately. Okay, not try. Please reply privately with the solution so that others can also think. Okay, cool. Yeah, we'll do that that way only, Ashish. Okay, we'll make a new array from after doing mod 10 from all these numbers, but we'll have to keep a pair, right? We cannot keep a single array. You get my point? We need to map which two is a part of which number. Okay, so which number is mapped to which part, that we'll have to keep. So either we can maintain a frequency, either we can maintain a pair, or the other way I'll also tell you. Okay, so most of you have correctly guessed it. Okay, so tell me one thing. Okay, this is just a single digit. Okay, so what is the range of a single digit? 0 to 9, right? So what if we create a frequency array for these numbers? Okay, what will be the size of our frequency array? 10, right? And then we can sort these numbers in linear time, right? Correct? Okay. Any doubt in this? Any doubt in here? Any doubt till here? No? Okay. So, okay, cool. So the question is clear to you. Okay, and even the answer is now clear. So let's say now instead of ones place, we sort this by the hundredths position. Okay, we sort this array by the hundredths position. Okay, now the numbers which don't have a hundredth position will automatically have 0 here. Okay, is this clear? Okay, so if we sort by the hundredth position, okay, what will be the result? The result will be 12. Okay, then we'll have 78, then we'll have 112, then we'll have 361, then we'll have 432, and at the end we'll have 500. Okay, so this is sorted by the hundredth position. Okay, now let's sort by the middle position. Okay, by the middle position. Okay, when we sort by the middle position, okay, what do we get? If we sort by the middle position, what do we get? We get 500. Okay, then we get 12, then we get 112, then we get 432, then we get 361, and then we get 78. Clear? Is this clear? And let's say then if we sort by the 1th position, then what do we get? If we sort by the 1st position, we again get 361, 432, 12, 112, and 78. This I did just for the sake of explanation. Okay, let's say we do this in these 3 steps. Is it also okay if we put 112 before 012? So if you are traversing from left towards the right, which is the number that you're encountering first? You're encountering if like if you're sorting, okay, if you're using a equal to sign or greater than sign, then your 112 can come before or after 12, because both the ones position and the tens position are equal. Okay, but generally what we do, whichever number comes in the array first, as specified in this question also, should come first in the sorted array. Okay, this I specifically specified also this condition that whichever number is coming first in the array should come first in the sorted array. Is this clear, Vishalgiri? If this condition is not specified, then you can keep any number anyway. It won't be any problem. Okay. Now you saw that we sorted this by the hundreds position first, then we sorted this by the tens position, then we sorted this by the ones position. Okay, so we sorted them by all the 3 unit positions. Still, the array we got was not sorted. You got the point, right? We first sorted the numbers by the hundreds position. Okay, so all the numbers that are greater will go up according to hundreds position. Then we sorted the array from the tens position. All the number with greater power of greater number on the tens position will go up. Okay, and then we sorted with the ones position. So all the number with the highest one will go to the top. Okay, so did we get a sorted array? No, right? No. Okay, let's try the opposite way. Okay, let's try opposite. Let's first sort from the ones position. Okay, and if we first sort from the ones position, what do we get? We get 500, 361, 432, 12, 112, and 78. Okay, is this clear now? We sorted by the ones position first. Now let's sort the numbers by the tens position. Okay, now let's sort the number by their tens position. In this, if we sort the number by their tens position, what do we get? What do we get? Can anyone comment? Correct. 500, 12, 112, 432, 361, and 78. Right? And now, if we sort these according to the ones position, sorry, this is okay. Now, if we sort this using the ones position, what will be the output? By the hundreds position, sorry, by the hundreds position, what will be the output? The output we get is Is this the output that we will get if we sort this by the 100th position? Anyone have a doubt in this? No? Okay, let's move on. So we sorted this, and what we observed was that now we get a sorted array. In this case, what we got was sorted array. Correct? So what we can draw from this is that the most significant number, okay, the most significant number in the left side, when we are directly sorting using the 100th, we're already getting a sorted array. Okay, my bad, sorry. My bad. Let's say we had let's say we had another number here, and the number was 312. Okay, let's say we had another number here, and the number was 312. Now, if we do the sorting using the 100th position, will 312 come before 361 or after 361? Archit, according to the constraint given in the question, okay, after, right? After. So here 312 will become. Like this was just by chance that this array came out to be sorted. Okay, so in this case, 312 will be coming after, right? So is this array sorted now? No, right? Why? Because the less significant positions are not sorted. Correct? Is this correct? Okay, cool. So just keep in mind that start sorting with the least significant place. Okay, so the most significant numbers or place are sorted at the end. Okay, why? Because first we are sorting all the numbers according to their ones position. Okay, so whichever number will have what will it ensure? Okay, let me tell you what will this actually ensure. Okay, so let's say we have 32, 21, 45, 46 and 27. So when we actually sort them by their least significant digit, okay, what will we get? We'll get 21, 32, 45, 46 and 27. Okay. Now if we sort this by the second most significant position, what we ensured was that the numbers with the similar second significant digit are actually sorted. Is this clear to everyone? Right? So this is how we proceed. Okay. And this sorting algorithm, okay, where in a number we sort the array digit by digit. Okay, we sort the array digit by digit using the counting sort is called as radix sort algorithm. Okay, is this clear? Okay, now let's come to the time complexity of this algorithm. Okay, what will be the time complexity of the radix sort algorithm? So the time complexity, can anyone guess what will be the time complexity of the radix sort algorithm? Archit, what is B here? Okay, cool. No, Ankit, not correct. Milind, what is D here? Okay, correct. No, Chirag, not correct. Milind, little bit correct. No, Amit, not correct. Soumitra, correct. Okay, so let's look at the previous example. Okay, so let's look at this example. Okay, how many digits do we have? 3, right? How many digits do we have? 3. So how many times will we have to loop over all the numbers? How many times will we have to loop over all the numbers? The number of digits that we have, right? The maximum number of digits that we have, right? Correct? Adil, correct? Samitra, correct? So number of digits means that the number of digits in the maximum element. Correct? Is this clear to everyone? Into n, the number. Okay. So we are iterating over n numbers. How many times? The maximum number of digits in the maximum number. Okay. And what is the number of digits in the maximum number? Will it be log 10 base the maximum number? Is this correct? If we consider integer, okay, the int value. Okay. So that is the time complexity of radix sort. Okay. Now just one small question I'll ask and then we'll end this session. Okay, it's a very small question. Ankit has raised a hand. Just 1 second. Yes, Ankit.
So, I mean to say that in 32 digit or if we say bits, so at the end of the day, it's 9 or 10 digit in base 10. So, at the end, its complexity would be more or less equal to order of n only, 10x max.
You're saying that the complexity of
The whole solution would be at the end of the day order of n, because the maximum value of int, even if we take max value equal to integer, maximum value of integer, that would have 32-bit int or 10 ki something in 2 into 10 ki power 9. So at the end of the day, it's 10 or 11 maximum number of time. We know it's upfront.
okay.
So won't I say it's order of n only?
Let's not generalize this. Okay. So for large n, you can say that might be the case. Not order of n. Okay. Not order of n. You'll definitely have to consider the digits in the factor. Okay. So it will vary every time. And yeah, for large n, it will nearly be equal to order of n. For very large n, it will nearly be equal to order of n. But let's not generalize this. Okay. Let's keep it at log 10 base, log of maximum digits, maximum number base 10 into n. Okay, because we have to iterate that number of times over all the array elements.
No, I mean to say the maximum value of int which a number can store is some 10 or 12 digits. So at the end of this value log 10 base max number would be 10 or 12, 10 digits. So it would at the end of the day come out to be order of n. We know the output. had there not been a limitation on the data type, or if we were saying that it was a big integer or something like that,
Mm-hmm.
then we could have said that log of 10 base max. But for integer, it's order of n only.
Not exactly order of n. We can't say order of n. It actually depends upon the value of n that we take. Hello.
No, it should not anyway depend on order of value of n.
Uh,
It either if we say that it's a big integer or big number, like it could have 100 digit, 200 digit, then it makes sense to have it on the value of the max. But if we say that all the number are stored within the int range, then it's a constant value. Maximum value of int can be 10 digit number, or if we say it's long, then 18 digit or 19 digit number. So in that case, since we are at the end of the day, before the solution only knowing number of time we would be looping outer loop, so it would be fixed. So
Okay.
it would be 20n, so it's order of n only.
Okay, so just answer my question, okay? Hello.
Yeah.
Okay. Let's say you're doing this computation on your phone.
Yeah.
Okay. And one person is doing computation on his super laptop or super computer, let's say. Okay. The time will be depending upon that factor, right?
Yeah.
Okay. So will you say that as in what I'm trying to say is that will you say that quick sort is good for supercomputer and bad for laptop?
No.
Or bad for mobile phone?
No.
Right? So you should keep the conditions same while you compare two things, right?
Yeah.
Okay. So what we are trying to say is, yeah, your case is correct when we are defining the constraints that, okay, it is int and it can maximum go up to 10 numbers. But defining a general algorithm, we do not define it using any data type, which is what Ashish has correctly said. Okay. So if you're restraining yourself and saying that, okay, this is the limit in which we can store this, okay, then might be correct, because that is also constant, as in the number of digits will be constant. The maximum number of digits that we can get is constant, but we do not define an algorithm based on that.
Yeah.
Got your point?
Got your point. Thanks.
Cool. Okay. Okay. It's getting late, so I'll just give you a homework, everyone. Okay. And the homework is that the count sort that we used. Okay. How will we implement the count sort? Okay. For negative numbers. Okay. So this is a small homework for you guys. Okay. Hello. Is this clear? Is the question clear to everyone? The question is clear, right? Okay. So this will be a homework for you guys. Okay. And a little bit of sorting is left. Okay. So on Monday, no, that won't be required, Ankur. That won't be required. Just think about it, how you'll be doing that. You have to use counting sort only. Okay. A little bit of sorting is left, and just one or two question practice is left that I'll be carrying in the next class. The next class will be on Monday. So in that class, I'll be covering a little bit of sorting, whatever is left, and then we'll move on to the next topic. Okay. I'll start the doubt session now. I have 3 doubts from the previous. Yeah, next class will be on Monday. Is it on Wednesday? I'll check the schedule. So whenever the next class is, Wednesday. Yeah, today is Monday. Sorry. So on Wednesday we'll discuss sorting first. Okay, and just the remaining topics of sorting, and then we'll move on to the next topic. Okay. So that's all for today from my side. I'll be starting the doubt sessions. I have 3 doubts from the previous class, so I'll first clear those doubts, and then if anyone has any doubts from this class, then yeah, he can raise hand or post his question. Negative. Yes, that's correct. That's correct. Okay. So I'll just repeat the questions. The first one was about between the bubble sort and the selection sort. Okay. And there was a confusion on the cost of swapping. Okay. So the cost of swapping that we defined in the previous class was just hypothetical. Okay. In general, there are very few cases where there are almost no cases where bubble sort is beneficial, because the only reason we study bubble sort most mainly is because it's a very simple algorithm. One advantage of bubble sort is that bubble sort can be used to find whether an array is sorted or not. Okay, bubble sort algorithm can be used, a modified version of bubble sort can be used to find whether the array is sorted or not, but that also can be done in order of n with just one loop. Okay, so there's not much advantages of bubble sort. Okay, that was regarding that. Then the other one was order of one merge of a sorted array. Okay, so someone asked that. I just want to know whether that person is still there or not. So should I explain this or not? Order of one merge of the sorted array. Does anyone want to know the algorithm for order of one merge of sorted array? Okay, okay, cool. Okay, cool. So order of one means order of one space complexity. Okay. Okay, order of one space complexity. Now, what is the reason that we don't use this algorithm and we prefer the order of m or the order of n algorithm? The reason for that is that this algorithm takes order of m into n times. Okay, so let's say you are given two array of 1 and array of 2. Okay, and this array is of size m and this array is of size n. So this merging actually takes order of m into n time complexity. I'll tell you how. Okay, so that is the reason we prefer to use the one that we have already discussed in merge sort, which takes order of n time but uses order of n extra space. Okay, is this clear? Is this clear? Okay, cool. So let's take an example for now. Okay, so we are given two sorted arrays. Okay, so the two sorted arrays are, let's say 1, 7, 9, and 11. And let's say this sorted array is 3, 6, okay, 3, 6, and 8. Okay. Can you, yeah, I'll be explaining this part again. I'll be explaining this part using this example only. I just gave this information to you. I'll be coming to how this is m into n. Okay. So since we don't have to use any extra space, okay, what will be the output of this algorithm? The output of this algorithm is that what is the value of m plus n in this case? In this case, the value of m plus n equal to 7. Okay. So the output array should be an array of size 7. Is that correct? But we do not have an array of size 7. So what the output will be? The output in this case will be that the first 4 elements of the sorted array will be returned as array 1 and the later 3 elements will be returned as array 2. Okay, I'll tell you how. Because we cannot use any extra space. We cannot use any order of n or any extra space. Okay, so we are given two separate arrays of size m and n and we return the output using this only. Okay, how do we do that? We start with the last element of the second array. Okay, we start with the last element of second array, and what we do, we start comparing it with the elements of the first array from the end only. Okay, if we find that the element in the first array is greater than the element in the second array, okay, we insert this element here. Okay, so what our array 2 would be? Okay, Okay, what we'll do is 11 will come here. Okay, and where will 8 go? We will put 8 in the first array using the insertion sort algorithm that we saw. Okay, so we will actually find the correct position of 8 where we should fix it. So according to insertion sort, if you see the first number 9, is 9 greater than 8? Yes, 9 is greater than 8. So we'll shift 9 one position towards the right. So 9 will come here. Okay. Now where will 8 go? Is 7 greater than 8? No, 7 is not greater than 8. So 8 will come here. Okay. Then we move to the next element and we repeat the same process. We start comparing it with the last element of this array. Okay. So 6 is less than 9. So what we do, we bring 9 here again. Okay. So 9 comes here. And where will 6 go? 6 will be inserted at its position using the insertion sort algorithm. How? Is 8 greater than 6? Yes, 8 is greater than 6. So we shift 8 towards the right. Okay. Is 7 greater than 6? Yes, 7 is greater than 6. So we shift 7 towards the right. Is 1 greater than 6? No, 1 is not greater than 6. So we insert 6 here. Okay. And now we repeat the same process with the last element. Okay. So 8 is greater than 3. We bring 8 here. Okay. And now we insert 3 in the above array using the insertion sort. So 7 is greater than 3. 7 is shifted one position towards the right. 6 is greater than 3. 6 is shifted one position towards the right. Sorry. Okay. And 1 is greater than 3. No. So 3 is inserted here. Okay. So now can you see we have the array in sorted order? Okay. So the first 4 elements are in sorted order in the first array, and the later 3 elements are in the sorted order in the second array. Is this clear, Milil? Is the algorithm clear? Okay. Everybody else, do you have any doubt in this? Do you have any doubt in this algorithm till now? Any doubt in this? Yes or no, anything please? No? No doubts? Okay. And how the time complexity is m cross n? So this is of size n. So we iterate over this once. And for every iteration of this array, we iterate over this array to insert the element. So what will be the time complexity? M cross n. Is the time complexity part clear to everyone? Okay, cool. And the last question from the last class was, what if there are more than 2 repetitions in a wave array? So if there are more than 2 repetitions in a wave array, okay, the question is formed. So every question is formed so that it is solved. Okay. So when we introduce the equal to sign for all the arrays that are possible, even if we take all the elements as equal, there will be a solution. Okay. But if we remove the equality sign, there will be many cases where there won't be a solution. Okay, so that is why that is not asked as a question, and there is no particular algorithm for that. Okay, so if there are more than 2 repetitions so if there are no repetitions in the array, okay, then we can definitely remove the inequality. Okay, and we can solve the problem by sorting and then changing the sign, as in swapping the alternate elements. Okay, that case will hold. But if there are repetitions, you will always get a question with equality. You will never get the question without equality, because there is a possibility that solution will not exist. Okay. And in that case, there is one more algorithm for that, which we discussed that day, which someone suggested also, and I studied about that. That if you swap all the even elements, okay, so if you check for all the even elements, what we have to check is for all the even elements, we have to see whether the adjoining odd elements follow the condition or not. And if they don't do it, you swap it and you traverse through the array, you'll get the wave array at the end. You can try this once at your home. If you don't understand it, you can ask me again. So all the alternate elements, all the alternate even elements, okay, 0, 2, 4, 6, 8. Okay, you iterate over them and check if the adjoining odd elements follow that particular condition or not. If they don't follow, we swap those elements. Okay, try that once. If you still have a doubt, ask me in the next class. Okay, now regarding this class, does anyone have any doubt? So shall I close this class for now? Okay, cool. Thanks a lot. Thanks a lot, everyone, for joining. Okay, thanks a lot. Good night. Good night, everyone. Good night, everyone. Have a great day. I'll see you on Wednesday. Okay, and Wednesday we just have to cover one topic left in the array, and that topic is the stability of the arrays. Okay, so we'll discuss the stability. We'll solve 2 questions, and then we'll move on to the next topic. Okay. Good night, everyone. Good night. I'm closing it for the day. Okay. Good night. I'll discuss it in the next class, okay, Milan? I'll discuss it in the next class when everyone is there. Stability of a sorting algorithm, okay? That is what is the only topic that's left, okay? Good night, guys. Good night.